Good morning. Well, we're done with dynamics, but now we get back into kinematics and start talking about projectile motion in chapter 6. So the 5.4 there does not apply to our textbook. So kinematics, as we learned about earlier in the class, is a way to describe motion of an object. We have 4 kinematic equations that we've used a lot, and we'll be using those once again. And now that we are comfortable, hopefully, adding vectors and looking at forces in multiple dimensions, now we can look at motion that results from those forces in multiple dimensions. But typically the focus of this unit is to understand something called a projectile and the motion of that projectile. So a projectile defined is an object that moves through the air or space and is acted by gravity alone. So think about some examples for a moment. What are some things that might follow this definition? Great. You probably have a few ideas. Anything that, what's coming to my mind? Golf ball, bullet, bow, basketball flying through the air, soccer ball, any sort of ball that's flying through the air, cannonball, and all of these projectiles are going to follow the physics that we learned here today. One important thing to note is that near the surface of the Earth, due to the effects of gravity, all of these projectiles follow a curved path called a trajectory. And so you should be familiar with that as you've seen many projectiles in your life, I'm hoping. All you soccer players out there know that you kick the ball up and it follows this parabolic path. And what you might not know is that we can separate the motion of that projectile into components. And so if in this example here we're looking at a ball being rolled across a table and its velocity is constant, assuming there's no air resistance, and that's because gravity is not accelerating it in the vertical dimension. However, we look at this picture over here, and we've seen that before. That does show the acceleration due to gravity in the vertical dimension. So what we're going to do is we're going to combine these two motions. So one of the key ideas here, and if you learn one thing from this video, I'd like you to remember that the horizontal component of a projectile's motion is independent of the vertical component. And that allows us to treat the motion of the object in the x dimension separately from the motion of the object in the y dimension. And really what we're going to be doing here is 2 kinematics problems at the same time. So here's a picture which shows what we're talking about here, a ball being dropped vertically versus a ball being shot horizontally, both influenced by the force of gravity. You can see on the right here, this ball, the yellow ball, the vertical distance that it covers each increment of time is the same as the vertical distance that this red ball covers in each increment of time. So if we didn't know that this ball was moving horizontally, they're accelerating at the same rate due to gravity. It just so happens that this one is also moving horizontally at the same time, but that doesn't affect its accelerated motion in the y dimension. And really, is there any acceleration in the x dimension? No, not if we neglect air resistance. Whatever initial velocity we shoot the ball with, that will remain constant. And so acceleration would be 0 in the x dimension for the yellow ball. So 2 important things to notice. I think I talked about those already. Yes, I did. And that one too. We're doing great today, guys. Okay. At the instant a horizontally pointed cannon is fired, a cannonball held at the cannon's side is released. So this is explaining that picture. Imagine the red and the yellow balls are both cannonballs. Which cannonball strikes the ground first? And we'll do this demonstration in class. I have a neat apparatus to show you that models this. Both cannonballs will hit at the same time. So one of the misconceptions that I need to dispel, a lot of students will come in and think the yellow ball would hit after the red ball because the yellow ball covers basically a longer distance through space, and therefore it should have more hang time. In reality, that X motion, that horizontal motion, has zero effect on the vertical motion, and just because it's moving horizontally does not influence any vertical motion. Pause. I have a phone call. Okay. That was an unimportant phone call, in case you were wondering. You know, your car's extended warranty is really important. Anyways, that's the end of this lecture. My next video this week will work a couple examples of how you might approach problems involving two-dimensional motion. Thank you.